So I finally decided I'm comfortable enough to use wall power. As you can see by the handy dandy sign I've put up, now we have to actually be careful and we can't just handle our live circuits willy-nilly. Because you will get more murdered all day by this power. Not even joking. So just don't work on a live circuit, it's not worth it. But anyway, the point of this is to have a breakout wire that I can just plug into the wall wherever I happen to be, and to do so in a safe manner, so that I can use wall power as if it was a bench power supply. So I got this plug, and this is just off of a fan. I literally just had a fan, and I salvaged parts out of it, and this cord I just cut off. It was its power cord. It has this little door. It's adorable. There's a fuse in here. The actual cord itself has a little fuse. Absolutely get one of these cords if you can. I've never ever seen one before this, so at least in the United States, these are definitely rare. Perhaps other countries have more fused cords than we do. But in any case, this little door slides open, and you can access a fuse in there, so that's really neat. So I'm using this cord. And here you can see the door is closed, and I just took the end of it, and it was just like that speaker wire I showed you in another video. It's actually two cords that are joined, and then you can just pull them apart. So basically I just took wire cutters and I snipped them apart and pulled them apart, and then I cut off the snipped bits because you don't want to have nicked insulation. And then I stripped off a lot. This is like 2 inches. You want to have plenty to work with because you're going to want to wrap it around. And this is stranded. If it's flexible, it's probably stranded. These are what I'm going to use, alligator clips. The idea is that I'm going to connect one end of the alligator clips to these and then insulate them, and then the other end alligator clip will be easy to put onto whatever I need. I chose this instead of the other wire where it's just loose and I put it in a screw terminal. Because it's wall power, I wanted to be super careful. So the alligator clip is not going to just accidentally slip off and fall while I'm near. So that's for safety. But I just got these nice clips. And so basically what I did, remember I cut off a lot of slack? So I put the wire in the clip. I just put this wire in the clip and I wrapped it around. I basically just went back and forth to make a lot of contact. So it went through a whole bunch of the teeth, not just once, but like back and forth through all the teeth. And then I soldered it, and I discovered whatever these are made of, they must be made of aluminum or something. Or I don't know if it has to be aluminum, but in any case, the solder does not stick to this metal, which was incredibly annoying. So what I ended up doing was just putting a whole bunch of solder and trying to fill this cavity a bit. It still got the job done. It's making plenty of contact. It's just unfortunately not soldered to the actual clip. And here you can see that I have the heat shrink on ready to go, and you can see my regret and my fundamental mistake because getting the heat shrink on over these clips was difficult because they don't open anymore. So what I should have done, and what you should do if you're doing the same thing, is put the heat shrink on and slide it down here, because the rest of the cable's here. So put the heat shrink on and slide it down there, and then go ahead and do your soldering. So that way you're only pulling it up over the other way, and it's much easier. So I've chosen red for the, I guess you call it hot line, live line, and black for the, not the ground line, but the neutral line. Some people call it the return line. That's incredibly stupid. That is possibly the most stupid name for anything in electronics I've ever heard, and one of the most wrong as well. Don't call it a return line. You can call it a neutral line. So this line basically does not change potential, and the other one goes up and down, and there's your AC. So the black wire is going to be on the plug that does not change potential, and the red one is going to be the one that does. In the United States, with the 2-prong plug, the big one is the neutral line, and the small one is the hot line. And then the third plug would be the earth ground, which I don't have. So here I have gone ahead and heat shrinked. I slid it over, and it shrunk a lot. You can see from here to here, it shrunk a lot. Pretty good. I used a nice long piece, so it's all over it. And it didn't shrink, like the solder and the clip itself is far stronger than the heat shrink, so it's not opening the clip from just the closing of the heat shrink, so it's fine. And then I measured just the resistance. The red wire I was getting 0.4 ohms, and the black wire I was getting 0.7 ohms, so less than an ohm for both. So we have good contact. And this is actually measuring wall voltage, 123.8 AC volts, roughly, RMS, and you'll notice I am nowhere in this picture. I hooked everything up to the multimeter first, then I plugged the cord in, took the picture, then unplugged it, and then disconnected the wire. This is very important. Do not work on a live wall voltage wire. You will die. Probably. Anyway, that's all it is. So quick recap, I got a fused cord, which is nice, not necessary, but nice. You strip off a whole bunch. You put it through the teeth, back and forth to make lots of contact. Hopefully your clip the solder attaches to, but if it doesn't, just use a ton. Then you heat shrink it, and make sure that you have connectivity, and make sure you connected the right wire to the right wire, if you've color-coded it or labeled it in some way. And that's it. So do be careful, and I'll be seeing you.